Welcome to The Explainer. Today, we're diving into a really weird phenomenon in the world of AI, something you might have even noticed yourself. And thanks to a new paper, we finally have an answer to a huge mystery. So, let me just ask you this. Have you ever felt like an AI tool you use, maybe a chatbot or something, actually got worse after an update? Like, it learned a new trick but suddenly forgot how to do the simple stuff you relied on.
Well, it turns out you're not imagining things. Scientists have finally pinpointed the hidden reason this happens, and in doing so, they've uncovered a fundamental principle that could fix it for good. Okay? Let's get into it.
The problem has a name, and it sounds just as bad as it is: catastrophic forgetting. It's basically when an AI model completely loses its old skills when you try to teach it something new. This is a massive roadblock to creating AI that can learn and grow continuously, like we do.
And this is a really big deal. I mean, if we want AI assistants that can grow with us over years, they can't have digital amnesia every few months. We have to solve this forgetting problem.
To figure this out, we need to quickly look at the two main ways AIs learn. First, there's supervised fine-tuning, or SFT. You can think of this like cramming for a test with the answer key right in front of you. And then there's reinforcement learning, or RL, which is more like learning by doing. You get rewarded for successful trial and error.
This brings us right to the heart of the matter. If you want an AI to learn a new skill without messing up its old ones, which one of these teaching methods is actually better? Which one can beat catastrophic forgetting?
Well, when the researchers put this to the test, the results were pretty stunning. Both methods were great at learning the new skill, hitting about 90%. But remembering old knowledge, the SFT model basically flunked, its score plummeting to 30. The RL model, on the other hand, held on strong with a score of 70. That is a huge difference. So right away, here's our first major clue. It seems reinforcement learning can learn new things with only a little bit of forgetting, while that cramming method has to throw out old knowledge just to make room for the new.
But that just begs the question, right? Why does RL forget less? What's the secret sauce here? What's the hidden mechanism that makes it so much more robust? Is it the algorithm, or is it something else entirely?
The answer, it turns out, is a concept called KL divergence. Now, don't get hung up on the name. Just think of it as a number that measures how much an AI has to change its mind to learn something new. A really big change means a high KL divergence.
This led them to a frankly incredible discovery, what they call an empirical forgetting law. It turns out the teaching method itself isn't what matters most. The thing that actually predicts how much an AI will forget, with terrifying accuracy, is the KL divergence. The more an AI has to change its mind, the more it forgets. It's that direct.
And this explains perfectly what we saw before. SFT, the cramming method, can yank a model's thinking to a solution that's totally different from what it knew before. But RL is different. It's naturally biased to find the solution that's closest to its original way of thinking. It likes to take the path of least resistance.
The researchers even gave this powerful idea a name: RL's razor. You've heard of Occam's razor, right? The simplest explanation is usually the best. Well, RL's razor says the best solution is the one that requires the smallest possible change to what the AI already knows, the one with the lowest KL divergence.
So how does this razor actually work? It's a simple three-step process. First, RL learns on policy, which really just means it tries things based on what it already thinks is a good idea. Because of that, the changes it makes are naturally small and conservative. And of course, these smaller changes keep it closer to its original knowledge, which means, you guessed it, less forgetting.
And the proof is just right there in the data. The team tested other ideas, like maybe it was about changes in the AI's internal wiring or something, but nothing else even came close. KL divergence predicted forgetting with a near-perfect R-squared value of 0.96. It wasn't just another theory, it was the hidden variable everyone was looking for.
So let's just put this all together. We started with a super frustrating mystery, and we've ended up with a clear, measurable principle. The secret to lifelong learning isn't necessarily the teaching method itself, but something much simpler: minimizing how much the AI has to change its mind. And this isn't just some abstract academic idea. It's a roadmap. For anyone out there building AI, the goal is now crystal clear. If you want a model that can learn for life, you have to find ways to minimize KL divergence. This principle could fundamentally change how we build the next generation of AI. And this leaves us with one final, kind of mind-blowing thought. We've always been limited by this cycle of learning and forgetting. But if we can actually use this principle to build an AI that truly accumulates knowledge for life, what could it ultimately achieve? What problems could it solve?
That is the future this discovery might just unlock.